Good morning, 7th class students. Today we are discussing in our chapter 4 that heat, and our next thermometer is last class we already discussed about the clinical thermometer, and now we are discussing about the minimum and maximum thermometer. So I am reading here the book from the book textbook. Okay. So when you read a newspaper, you see weather report on the front page. Weather report, it means what is the climate report, what is the maximum and minimum thermometer on particular day, what will be the average. So it is the average temperature, okay, minimum and maximum temperature. So what is the average temperature of the whole day, and what is the temperature of what is the maximum temperature during this month, okay, I mean last few days, or what will be the what will be the maximum temperature and minimum temperature in coming few days. So the weather report above is prepared with the help of minimum and maximum thermometer, and you know about that. You already read at the front page of that newspaper written that adhiktam tapman and nyuntam tapman. So adhiktam means the maximum temperature, and the nyuntam means minimum temperature. So nowadays you can see that the minimum temperature is like 20 to 24 25 degrees Celsius, and maximum temperature is 30-32 degrees Celsius or 36 degrees Celsius. Okay, so this is the way where which through which we can explain the temperature. Okay, so the picture of minimum and maximum thermometer is shown here. So the minimum and maximum thermometer scales are numbered in both degree Fahrenheit and degree Celsius. Is range from minus 28 degree Fahrenheit to plus 121 degree Fahrenheit. It means minus 34 degree Celsius to plus 50 degree Celsius. Okay, so this is the range of our maximum minimum thermometer in the degree Celsius. So the minimum scales on left reads downwards, while the maximum scales on right reads upwards. Okay, so right one, it means the right one reads the maximum, and left one reads the it means the upward, and left one is for reads downward. Okay, and right reads upward for the maximum. It means that minimum scales on left reads downward. Left, okay, this is the left side, and this reads the downward or minimum temperature, and this right one reads the maximum temperature. So minimum and maximum temperature are indicated by markers above the mercury column in the scale. This thermometer can be used indoors or out. It means you can use this thermometer in indoor as well as outside also, because it is a very few in mass or weight. And lab thermometer is clinical thermometer is meant for measuring the body temperature only. So then how can one measure the temperature of other objects? So lab thermometer is it means measuring, the clinical thermometer is meant for measuring body temperature only. Then how can one measure the temperature of other objects? Okay, so like that, you know about that digital thermometer and clinical thermometer. Clinical thermometer we already discussed, and you know about that this thermometer is generally we are using or doctor are using to take the temperature of human body. But not only the human body, sometimes we have to detect or measure the temperature of objects also. So how can we measure this? So we will take the help of this lab thermometer. It is a laboratory thermometer which can measure the temperature of other objects. It consists of a thick walled fine bore glass capillary tube, and the capillary tube has a small bulb at its one end, and this bulb and some portion of tubes are filled with the pure mercury. So same type of like a clinical thermometer, lab thermometer also a long one thermometer in which there is a bulb, and in which bulb is filled with the mercury. The strain is graduated in degrees, usually from minus 10 to 110 degrees Celsius. So the range of laboratory thermometer lies between minus 10 degrees Celsius to 110 degrees Celsius. So this is the range. It means up to 120 total. It means in the during this, because minus 10 to 0 and 0 to 110. So this is the 120 degrees Celsius of range of this lab thermometer. Okay. We must find out the values of one small division on the laboratory thermometer. You would need this information to read a temperature on this thermometer correctly. So is lab thermometer useful to measure human body temperature? Let us perform this activity to answer these questions. Okay. So it means the clinical thermometer we are generally using to we are generally prefer to use the human body temperature. But can we able to take the human body temperature also with the help of laboratory thermometer? So look activity 4.4. So to measure the temperature of a tap water with laboratory thermometer, a requirements a beaker with the tap water, a laboratory thermometer. Okay. So fill 2 upon 3 of the beaker with the tap water and dip the laboratory thermometer along with the bulb in the water. So the bulb should not touch the bottom or side of the. Okay, so this is the activity 4.4 on page number 839. And how can we measure the tap water temperature? Tap water temperature with the help of laboratory thermometer. So it is very easy to see because we need one beaker filled with tap water and we need one laboratory thermometer. So fill 2/3. This is the 2/3. It means at least 66.66% of water can be filled in one beaker, and then dip the laboratory thermometer along with the bulb in the water. The bulb should not touch the bottom. Okay, we should not touch. Okay, the bulb of this should not touch the bottom of that beaker, and you will observe that the mercury in the thermometer, that tube starts rising. Starts rising, and at a certain point it remains fixed, which gives the temperature of water of the tap. It means the how the what will be the temperature of the tap water. So we can measure by this easy process or easy activity. Okay, and when the rising of this mercury will be stopped, okay, then we will measure the accurate temperature and we will write down the temperature of this tap water. So also through this way we can measure the temperature of different type of waters or anything. Okay, here also. Okay, and to measure the temperature of different things by different thermometers. Okay, so now we need for that, like that activity we are performing here, it is only tap water. Here we are taking some hot water also. So lab thermometer, clinical thermometer and antiseptic solution. So first of all we take hot water in a beaker, deep laboratory thermometer in hot water. This we just keep inside the hot water so that the bulb is immersed in water but does not touch the sides or bottom of the container. Wait till the mercury thread becomes steady. It means mercury thread will be the, it means the in between that will be the steady, it means the stop. Take the reading of the thermometer. Now take out the thermometer from hot water. Okay, and take reading of the thermometer. It means we are just taking the reading of the thermometer, because it means we are just measuring them. Before that we are measuring the temperature of the tap water, and now we are measuring the some hot water. So this is the hot water, and through that we cannot touch this bulb to the at the bottom of that container or beaker. So through that we can measure the temperature of hot water. So you will observe that as soon as you take the thermometer out of water, the level of mercury begins to fall, because due to that hotness it is going to be a rise, and when we are just taken out from the outside, then ultimately the this level of mercury is going to be downside. Okay. So measure the now wash and rinse the clinical thermometer carefully. Measure the body temperature of classmates while keeping the thermometer in the mouth, and after taking it out from his mouth, what do you observe? You observe that the mercury thread remains in the same position in the mouth of or out of the mouth. Okay, so rinse the clinical thermometer carefully. It means if we already seen that what precautions we can take care with the clinical thermometer. It means before to use and after use we just wash this clinical thermometer. So same procedure we are just doing with that. So now wash and rinse the clinical thermometer carefully. Measure the body temperature of a classmate. Okay, we can take any class student and we can measure the temperature, and keeping this thermometer in the mouth, and after taking it out from his mouth, what do you observe? You will observe that the mercury thread remain in the same position in the mouth or out of the mouth. Conclusion: from this activity we can conclude that temperature of anything with the help of laboratory thermometer must be read while the thermometer is touching that thing. Otherwise it is inconvenient to use a laboratory thermometer for measuring human body temperature. It means if we cannot touch with the particular body or particular object, then we cannot able to measure the accurate temperature with the help of this thermometer. It means the lab thermometer. So reason, clinical thermometer has a kink near the bulb which prevents mercury level from falling on its own. So therefore the level of mercury in the system remains the same. So there is a kink like it is placed near the bulb which prevents mercury level from falling on its own. So therefore the level of mercury in the stem remains the same. So that's why the outside the mouth or inside the mouth there is the same of that mercury level. Okay. Next is our transfer of heat. It means how the transfer of heat can be possible. You know about that from we are just when we are telling that transfer of heat, then we are saying that there is a three process for to make them understand. That is, okay, conductions, okay, and convections and radiations. Okay, so three are the process. Like first is conductions, convections and radiations. Okay, that is the radiations. So first of all, behavior of solid, liquid or gas changes when heated or cooled. Okay, so you know about that. When we are giving heat to ice, they can convert into liquid. When we are giving heat to this liquid, then they are converted into gas. And when we are giving to cold, it means the temperature, then this gases they can convert into liquid. When we are giving same type of cooling to this liquid, they can freeze into a ice. So you know about that. Solid, liquid and gases, okay, are just changing their states of matter with the help of giving the heat, or losing the heat. So at the same time there is an increase in the size of body called expansions. So same time if their body is increasing size, then we have to tell expansion. Expansion means it means increasing the body size. So when a body is allowed like that expansion, if we are giving too much heat to the solid iron, then they are just expanded. Okay, they are just expanded, and molten iron they can change, and we can make new things with the help of that. These change can be observed with the appropriate experiments. Heat is a form of energy. It flows from the higher to lower temperature. But how does this happen? The methods by which heat is transferred from one region to another are called modes of transfer of heat. So we can tell. So heat is transferred from one region to always to another region. You know about that? Like that. We are taking a cup of tea with a very hot cup of tea. Okay, very hot cup of tea. And after that, we are taking that there is a continuously evolution of some vapor form. But after that, this heat is just transferred to the cold surface. Okay, this is the hot region, and this is the cold region. So there is a change of, or maybe the transfer of this heat from hotter region to colder region. So through this example, and after that you can see that this hot tea is converted into like a room temperature like tea. It's not too much cold, but like a cold of, and like a same type of room temperature like tea. Okay, so this can be easily show that the hot objects or hot things are always getting to attain the temperature of room temperature. Okay, so there are three mode of heat transfer, that is conductions, convections and radiations. So first is conductions. In this process, heat is transferred from the hotter to the colder end of the object through the vibrations of its molecules about their mean positions, and definitions of the process of transmission of heat energy in solids without the actual movement of particles from their position is known as conduction. So it means that conduction, it means the process of transmission of heat energy in solid without the actual movement of particle from their positions. Okay, like that one utensils we are taking one have a big that means we can tell a big spoon. Okay, this is the big spoon for us. Okay, and if we are keeping in this hot or boiled water, okay, in this hot or boiled water, okay, and there is a flame of gas, okay, flame, and due to this flame, this solid is getting the heat. This means after some time you will see this is also get converted into the hot region, which is earlier, which is not a warm this object, but now it is converted into the hot objects. Okay, so this is showing that how in the conduction the transfer of heat from a solid substance, the transfer of heat from the heat in the solid substance without the actual movement of particles. So there is no actual movement of this particle to goes to here, only because they are just nearby each other. Then one is get hot, other is get hot. Then it's way. This is the way to get hot this regions, and that's why we are feeling to touch here also getting hot things. Okay. So from there, position is known as conduction. So this is showing that conduction process. Okay. So next some activity 4.6, 4.7 we will study in next online classes. Okay. Thank you.